Okay, my outstanding friends, everybody knows Bill Nye. He is the science guy, and he's been messing around with something called cognitive dissonance, where really you can't deal with the reality that's put in front of your face. He says it takes 2 years to recognize reality once you realize that you've been wrong your whole life, and they're having a hard time with it. It's taken 10 years so far, and they still haven't realized they're wrong. But I will show you, Bill. Now, Bill knows everything about science, and he knows that light is light, and it only goes one speed, except for now, Bill. I can show you that we can accelerate light, and we did it because we used a Venturi. And that Venturi also created some very unusual things. So the light is here. The particle, and I will show you the particle, creates the wave because the particle is a magnetic particle, which is basically like two bar magnets together. And here they are, Bill, right there. All right, 2 bar magnets, black and white balls. You see them? And as that comes through, they spin. The white ball charges up, and then it does a flip, and then the top one comes to the front, and the bottom one goes to the back, and then they explode at the Venturi right here, cause nuclear fission because they split, and then they come back as nuclear fusion, and in between we have atomic energy, and we should be able to get free energy using this device, Bill. And I believe just basically collecting it with a solar harvester at this point after it comes through the Venturi right here. So I don't see a big issue why we can't have free energy, and it is the muons, and it is the whoops. There you are, Bill. How you doing, buddy? Let's go back to, hold on one second. All right, let's step back a smidge here. Again, this is the light accelerating. That is the particle that I showed you was the 2 blacks and 2 whites. And Cornell knows about this. And Bill went to Cornell, so he should know about it. 2P2H. Why don't you call your buddies up at Cornell? That is the particle. That is acceleration. That is concussion. That is explosion and fission, and this is fusion. And here I can show the black and white particles dividing. And the black ball is dark matter, and it is a muon, and it is gravity, and it will not compress. The white can compress and get through our very extremely sophisticated, tuned Venturi belt. So these are the particles that CERN and Fermilab can find, and they say muon neutrinos, electron neutrinos, and they're attached together, and the black ball is gravity and dark matter, and they see it, they know it's there. And then now they're calling them sterile neutrinos when they're no longer attached to the electron neutrino. And this is what we have here, sterile neutrinos. They're no longer attached to the white. But when they were attached, they were electron and muon neutrinos attached together. When they concuss, the muon becomes a sterile muon, and the electron shower comes through here. Now, Fermilab thinks that they can see muons just keep going forever, all right through the Earth. No, they're going to come back to muons are gravity, dark matter. Only thing they want to do is get back to that white particle, which is coming through here, and at this point it's separated. It's just 100% whiteness. Brilliant whiteness. But see all these black balls? They're all exactly the same. They don't mind being on top of each other, next to each other, have no problem whatsoever. But they do want to be back with those white ones. And here they start to come right back at this exact distance away from the Venturi. Now, this is not speculation. This is not even theory. This is evidence. And I can tell, and I am going to be showing this. I got some things going on, but I will be demonstrating exactly how this Venturi is constructed, and the materials that probably could enhance it. I don't know how the harvester should work. All of that stuff. I have it all figured out. I've been doing this for many years now, and now that I fully understand it, I believe. And I have seen it for enough times that I believe, I understand it better than anybody else. Nobody's seen these particles before. Nobody in the world has seen this particle except a couple of us. Rod and I and Fabian and Dylan, we've seen this particle right here. Well, I mean, CERN, what's her name? Cornell has seen them, but they just lost track of them. That was 8 years now, 10 years ago. And these are the 2p2h particles. And we can see them charging up. I could tell you that white squirts through that Venturi. This will not. They can't make it through. They hit like a brick. They bounce off. These go because of the pulsation. I believe it's got to do with the pulsation and the size and the non-crushability of the dark matter. And these can crush, so they can get squirted through the Venturi. These can't. And they say they make up 85% of the mass in the universe. I have no idea about that. But I can tell you what, I would think that this is heavier than the white one, although I don't know that for a fact. But I can see they can get smaller and bigger. They can charge and discharge. That's what light is all about. Charging and discharging so that we can see the radiation. You're never going to see that ever. So nobody's ever seen dark matter before. This is the first time you've ever seen it. Okay, like I say, Bill, I believe you did go to Cornell, and this is where this is from, Cornell University. This goes back to 2013. Now, I showed you the two-particle, two-hole, 2p2h particle that is light. That's a photon. They didn't realize that. They call these electron neutrinos and photon muon neutrinos and so forth. But they did realize that this creates excess energy. And listen to this. Understanding of the so-called two-particle, two-hole, 2p2h effect is an urgent program in neutrino interaction physics. Such processes are believed to be responsible for the event excesses observed by recent neutrino experiments. That goes back to 2013, and it seems to be they dropped it for 8 years. Now, and there's 3 articles here, and then now they have been talking about the spontaneous sterile neutrino, which is that black ball separated from the white. That's the sterile neutrino. That is dark matter. And you guys understand this up at Cornell a little bit, apparently, because even back in 2011, this was a new nuclear radioactivity, because it is fission and then fusion. As it splits and comes back, I think you've seen that, Bill, and these are the kind of things I want to debate you on. So we're going to look at your video, and then we'll go through and see how, maybe we can talk. All right, just to sum up before we get into your video. This is light, just from a red laser, pulsed. Bip, 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 bip. This is the little particles that are in the air, the electrons. They're being concussed by this magnetic field, because they have magnetic fields. They glow. This is the particle I showed you, the 2p2h particle, pretty obvious. This is light accelerating. Obviously, there's no question that it's accelerating. I would think you would agree with that, Bill. I mean, I can't see anybody would dispute that. Now, we saw that the particle was here, and the particle was the black and the white ball exploded here and divided. So we saw it was attached as the neutrinos back to back. It creates a basically stable photon. If you just have one, it's an electron. It's pretty aggressive, the electrons. That's why they want to incorporate into something. These bounce from the magnetic fields they bump into. The other ones get incorporated into those magnetic fields in many cases. Sometimes they just sort of click on and attach magnetically. But sometimes they actually invade, and that's what being electrocuted is. It boils the water and so forth. Anyway, we just saw the particles divide. I mean, that's it. This is fission. The black came away from the white. That's fission. No question that happened. Now, the white is the showers, the white electron showers. All right, the muon stays the black ball, and there it is right there. So we did it. We created fission. That's fusion. This is nuclear energy, just exactly like Cornell said. It's a new nuclear radioactivity, and it is radioactive, but only in just this much of light distance of light. This is not radioactive like you think about radioactivity of gigantic chunks of heavy particles. We're starting with light, so we're starting with something that is so tiny, and it fuses right back together here almost instantly. So this is not dangerous, I don't think, by any means. I mean, we could check it. I have, little Geiger counters and stuff. I don't do the experiments here. Rod does them in Australia, Rod Warren. He discovered this literally by accident, and when I saw it, I knew what to disproved my theory about the electrons and everything being dipoles, because there is nothing but dipoles. And that I also want to debate you on, Bill. So let's get into your stuff. I showed you my stuff. I showed you light accelerates, light is a particle, light can separate. We got your muons, we got your electron showers, we got your radioactivity, which is nuclear energy. And it is gigantically increased energy. Absolutely enormous. Just blistering energy, right? Absolutely phenomenal amount of energy. From what started back here, there was almost nothing until it starts to stack up. At the Venturi, there is virtually no interaction back here. That's why we're using CMOS smartphones. And you go back and you look it up. What smartphone uses cosmic ray detectors, and they can use them and they work fine. And the reason is because the particle is so enormously energetic, it can pick it up, and then it pixelates it, and then it creates an image of what the energy values are. Back here, there's no energy value at all. You're not going to see anything. It just doesn't have enough energy to turn the CMOS on. Here, it's literally exploding the CMOS chip. I say, whoa, baby, look at that, and just. So, Bill, that's what I want to talk to you about. Is getting free energy is the basic part. You know, and I need somebody like you that has, you know, kind of a big footprint to help me out, or tell me I'm crazy and send me on my way. But I do need to discuss it with somebody. Okay, so I do these debates in absentia because I've tried to contact virtually everybody. I don't know if they get my emails or not. I've been put on so many spam lists, I don't know if I get through to anybody. But I am trying, so will he debate me? If not, it's in absentia. I'm ready, Bill. Conflicting evidence. Change your worldview. Well, let's see if he can change or he can even think about what I'm showing him. All right. I looked at this head extremely carefully, not for 20 seconds. I spent a lot of time. You see that? That's the cartilage of the nose, and that's the flesh from the nose splayed away from the nose because somebody stepped on the back of his head or something, or his head was laying flat on its nose, and the tissue just walked away from the cartilage area. Now, what is this right here? What is red and black? Scott Walters, oh yeah, just ferrous oxides. Well, ferrous oxides are from red blood. Red and black blood is ferrous oxides. Red is the red artery blood. Black is the used blood, the vein blood. And this head is caved in. And this is blood. I mean, it could be tested now, no question. Back then, I was the first one to get DNA tests done on, and I believe in the world, on the ancient humans, and for sure the ancient giants. I don't think anybody else has done it at all on the ancient giants. But I got them on the, I was believe this was like 2015 I had my test done. I think it was summer of 2015. And it took a little while to do it. It took several months. And this was also being CAT scanned, and my stuff was being, I had 7 CAT scans done by Jesse Grant and Associates, and absolutely fabulous job. Now, I was using a different software platform then, and I moved to the Linux, and it's not compatible, so I can't remember what, but and there wasn't a whole lot of detail to be seen in the CAT scans, but I will show you one that shows, I have the piece here, and I can show you why it's not real easy to see the parts. But this, there's no question, this, they caved his head in, and there's a little poke right down through the center in the middle there. It looks like maybe a knife blade went down in there from the CAT scans from this. We got the CAT scans, and they were terrible, absolutely terrible, compared to what Jesse Grant did. Jesse's was like fabulous, absolutely unbelievable. Jesse Grant's Associates, absolutely unbelievable, incredible work. Nicest people you ever want to work with. Let me show you that CAT scan, and that's all I can show you really of the, unless somebody wants to look at them. I still have all the files. I think I got to replace the software. I really can't remember. This goes back years and years ago. Anyway, let me show you the quick CAT scans. And this guy, this is a cap he has on. Jim slid a playing card right up in between the cap and the head. It could be removed, and it's not like a helmet or anything. It's like it's got a weave to it. You see the weave? You see it come up over and under and up and over and under, and I think this is doing the same sort of, I think it's like knitted or something like that, a cap. And that's the bone black, they call it. And the red is from the red blood. And anyway, let me show you the other thing. All right, I really want to give a ton of appreciation to Jesse Garant and Associates, Fabian, and all those guys out there. Absolutely fabulous guys. They do some of the biggest things in the world. They do car engines and everything else for huge corporations. And Jesse, I can't thank you enough, my friend. And they did it all at no charge. Look at the people they do. It's Rolls-Royce, Ford. I mean, they are the best, absolutely the best. And they were so nice and so helpful, and didn't charge me anything. All I had to do was pay for the shipping, and boom, they did it. And I'll show you the CAT scan I have. Now, again, I have all the files and everything, but when I changed the software, I think I don't know what happened. I can't remember, but you know, you don't see a lot, and you're going to see what I show you. You take it away for what it is. But this goes back to 2015 when I did released all this information. I had all kinds of stuff on the web, and it really got destroyed. Most of it got so trashed I took it down, and then I started a whole new station, a whole new channel. I don't know, a year or 2 years later, or whatever it was. So let me show you the CAT scan, and I will show you the offset thumb bone, and I think it's the thumb. Okay, these are the kind of details really that you need to focus in on. You see that is the back of the bone, and this is the bone piece right here. That was where the tendons go. This one here, I believe, is the red blood, and that one there is the vein blood, the black blood. And they run up the sides. You can see them perfectly, exactly identical. You see the core in the center, and then the dark blood around it, and then the not dark. Now, I broke this piece off, which was attached to the bone, just to see how, you know, what's going on inside it. You really can't see much of anything. But if you know to look for the different colors, you can tell the chemistry based on the oxidation states of the iron, basically. Now, you see that bone right there? Now, this was a left hand, and it was upside down laying there. I said, if you looked at it, you had your bumper pad here and the thumb running off. Now, it would have been laying like this. You see the bone right here? It's not way over in the middle. It's not in the middle. It's way over to the side. And I said, well, that's not normal. Did the guy die laying this like this and the bone drifted down here? No. He died laying just like this. It's offset because it's offset on your hand. And I couldn't believe it when I looked at that book. It's not offset on the book. And I haven't seen anything else in that book that isn't right. You see this? Look at your finger. You see the bone on one side, it's flat on the thumb. On the other side, you got a bump sticking out. Same thing with here. The left one here is the bump is on the outside. And that's it. The bone is here. So what can we see in the CAT scan? You cannot see a lot because this is called nucleophilic substitution. They say, oh, that's just a rock. That's just basalt. That's just limestone. That's just whatever it is, mudstone. Well, the outside of all of this stuff, they call it feldspar. Well, feldspar is nothing but collagen fabric. And it wraps all the bones, and that's what separates them. Originally, I was going to call this, and they call this fascia. Fascia, skin, wrapping, coating of the organs, membranes, all the same thing. It's a separation of tissues. Within your body, it's a membrane. On the outside, it's skin. And around your bones, it's a membrane too. But they all have a certain chemistry. Now, like, oh, don't forget now, this was DNA tested, human. There it is right there, bingo. This was DNA tested, human. And this, I got the blood out of here somewhere. But this is the fascia, and this is really heavy duty, they call pleura. Your lungs have to go all day long. This is a big rubber bag. Now, bones, they don't expand and contract or anything, so they don't have to have that big rubber bag. Now, your skin has to be kind of rubbery and supportive of all the tissue underneath, so it can stretch and do this kind of stuff. And underneath that, there's a thing they call interstitium. We're going to get into all of this stuff deeply when Bill gets a hold of me because he wants to know more about mud fossils, and I am glad to teach him. And Caesar will be here to help. He'll keep an eye on everything. That's my buddy, my best friend now, Caesar. Caesar Augustus. Now, let's see what else we can see in the CAT scan, but that's the bone. And we will see the bone, you'll see the pattern of it, but not much more, because like I say, nucleophilic substitution means a total invasion of the chemistry. So here we go. Is this all visible? Yes, it is. All right, so that's not a bad image there, and we can very easily see each side is, that's just not an accident. I mean, come on, please, 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 y'alls. Very, very good at this stuff. You don't know. Whoops, hold on. There's a guy talking in here. He's a loudmouth. I'll shut him off. All right, here we go. All right, so now I came from that picture of the thumb, and now we're looking at the CAT scan. And you can see all the blood vessels coming up, and that's how they service, and this is coming up from the bottom up. Now, you look over in here somewhere, I can't even remember now, I'll show it in a second. It's hard to see. There it is, there it's coming up now. You see it? Look for that pattern. Let me home in on that. Again, it's nucleophilic substitution. That means that there's an invading group and a leaving group. The invading group is the same bunch of guys, and they take over all the chemistry. Now, there's going to be little tiny spots that aren't exactly the same, and that is the pattern of the bone. And I have one here I should show you, which I will. Now, he's going to go deeper and deeper in. Oh, well, I'm showing it here. We're pointing to things here and there. But anyway, that's what you can see. I don't think you're going to see much more than that. That's about the, you can see the circle in there, which was where that bone was. Now, let me show you a bone that you can actually see very well and see the muscle that goes along with it. All right, remember I told you the book is so perfect, it's almost unbelievable how precise it is. Well, here is a fingertip. Okay, and it's actually this part here running out. The bone ball is right there, and that is the bone ball. Okay, you see this? And you see that? That is this tendon ligament. It comes down and breaks right there at the abrupt transition. It's on the other side of this finger. There would have been one right here, just like that, splaying off just that way, except this one broke off and left the bone ball. This side still has the tendon, which is here. And guess what? It has the muscle right here. I put a little water on it so it would show up better. That is on the other side of the bone ball. You see that? There's the bone ball right there. Right down the side. There's the muscle, and the tendon still attached on this side. Just like that. Broken right there, and the bone ball is underneath the muscle fiber, which is here. See all the muscle fibers wrapped around? Well, can you see that? No, probably not. There's all kinds of anatomy going on here that I can see. There's no question what it is. Now, the bone ball itself, when I talk about nucleophilic substitution, let me back out of here a second so you can see all this here. All right, now, when we talk about nucleophilic substitution, it means everything got invaded by really what I normally call mud fossil, bloody red tissue. It's biological stuff. Right? And there's the bone ball here, and it would have been, and it wraps right under there. So here's how it separates. You see, this is the calcified portion. It's a little bit different, but it's still basically the same type of stuff. All right, so you can see it's a little bit different when you line it up side by side. This is turned into mud, basically, because this had a lot more red fleshiness to it, which is inside the bone. The outside cap of the bone is a totally different, the marrow and so forth is inside the bone center. It's quite a bit different. Now, and then this, of course, is the tendon. And that is the flat spot that runs right up the finger. Can you see that? Yes, you can. Runs right up there. That's it right there. You see? That's it right there. And that's the bowling ball, which is underneath here. And this part is broken away, so we're missing this. But on the other side, it's there. You see it? It should be on both sides, here and here. Instead, we have the bone ball, because that's gone, and we have the muscle and the tendon. And the tendon that runs right down the back of your finger, exactly right there. You can see that flat plate? That's why I say this is so specific, this book. You can see every muscle, every fiber, every blood vessel, every artery and vein and membrane, and I mean, it's just incredible. And I find all of these bones. I can find these exact bones from the hands, and where you see these little pock marks, that's where the tendon entheses were. And that means that's where they anchored into the bones. You see the anchor here, anchor here, anchor, 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 anchor. And then at the very tip, there's that apical tuft. I have one around here. Here it is, right here. You see at the very, can you see that up there? See at the very tip, that's the apical tuft. And that's a ball which has the straps come down from these balls. And there's a ton of them locked in there. And they run down to here and over to here and so forth. And that's what lets your fingers be pulled back and forth. It's very cool stuff. And this one here also has the apical tuft. You can sort of make it out. Let me see if I can point you down at this here. You see it right there? You see that round little spot? That's this. And there's tendon balls all around it. And that's what makes your fingers tough. I mean, your fingers are tough little buggers. So anyway, that gives you a little anatomy there, my friends. All right, so that guy who was just talking says, if everybody around you doesn't agree, it's probably wrong. Well, I'll tell you what. Everything I have is testable right now. I extracted these samples from things that I have here on my property, and I will show you the things. And then I sent those things that I extracted, and I extracted them right from the arteries of the creatures' body parts that are on my property. And I can find the artery very, very simple. And it was excellent quality DNA. This goes back 6 years ago. I'm right down the street from Yale. They refuse to engage. Harvard refuses, everybody. So don't tell me that everybody's open to looking at something that has evidence. They're not. When the evidence is against them, they refuse to engage. And that's what I found straight across the board. Let's see if Bill's is different. Excellent quality DNA sequences obtained for the 36-inch tip. I'll show you that fingertip and the lung, and I'll show you the lung. And it was Homo sapien mitochondria. That's the mother's side, these different regions in the DNA. And that signifies, no question, that that series of particles in that sequence makes no question whatsoever. It is the structural information in the DNA that is in the mother's human mitochondrial DNA. This was a certified lab, certified test. It was done by Helix, and they sent it off to do the blast, I think, at Eaton Biolabs or something like that. The products were submitted to Eaton Biolabs. Anyway, this is not a silly test, and I have the stuff here, so you can see it. And let me just show you what it is. And if somebody wants to test it, good enough. But right now, what I have heard from every single one of them, oh, you must have contaminated, you must have done this, you must have done that, and then it's just dead silence. Well, let me show you. And if you're that incompetent as to just turn away from this, or you just turn away from it because it affects you, then the words that are being said right now are absolutely meaningless. All right, that had excellent quality DNA, and the reason is that is a fingertip. From here to here, it's approximately 36 inches, I can't remember, but I think it's 36 inches about. That's the fingernail. This is the little bone pad that bumps up against your next bone. All this is the tip of, I think it's a finger. I believe it's a finger. It could be a toe, but I believe it's a finger. And I broke this piece off the side here, and that's where your fingerprints start. So there should be some fingerprints on it if it was this good to be seen like this, which there are. And here's the fingerprints. All right, that's the side where the fingerprints are. And that is the grip skin, and it is very, very thick. That thing's about this thick. And my thumb is about the same width as one of these fingerprint ridges. These are the sweat pores that come out of a fingertip. It's what it is. And this is in my backyard. Now, I also had a lung done, and that is here. Hold on a second. Where are your lungs? I got so much stuff here. This is the one that I had done, was this one here. And let's see, this is where I took right out. It's just saturated with blood. There's a flap there that's just absolutely saturated with blood. I drilled up inside there, underneath here. It's absolutely saturated with blood. And this one here, blood ran all over the counter. I mean, it ran all over the counter. And here's the alveoli. You see them here? So I would say those are lungs. The DNA says it's a human lung. I mean, these are the patterns of the lobes of the lung. This is the actual blood that ran out of that other one. This is blood. Blobs of blood. And I got this all over the place. This is not the one-off. I mean, you could pick them up all day long and get blood out of them. Blood runs right out of these rocks all over the time. Now, where else I got? This was another giant hand that I had DNA tested. That's the hand. This is a left hand. Put your hand out like that and splay it out. You're going to find that you have a tendon running down. This is the grip skin again. Remember before I showed you the grip skin on the other fingertip? Well, this is about, I don't know, 3 or 4 feet wide, something like that. And this is the bumper pad around your hand. This is the grip skin. And this is where the thumb goes off to the left. I have the thumb. I've had the thumb CAT scan. Well, actually, here it is right here. Oh, that's the thumb. And that's the bone of the thumb. And the reason I know it's a thumb is the bone is offset. And this is the left-hand thumb. See, the bone is over here. If you lay your hand out like that, you'll find this is the flat side and this is the indented side. That's the flat side, and this is the indented side. And that's why it's offset. And that's the pads underneath. That's the apical tuft. You got to get to somebody in medical school. Like I said, I studied all this stuff, and I did it because I was refused to be discussed. And that's why I have to do this debate series and show the things that I show and say, is your mind open enough to see this? Do you have to say, oh, I can't allow my mind to open that wide enough, it's going to fall out of my head? It might. It just might. Because your head is so solidly constricted that to crack open your head, it may fall out. But if your head can sort of stretch and absorb like a little sponge, well, you're going to be okay. Lighten up, man. Pay attention. Okay, like I said, I will debate on any science subject whatsoever. What do we observe around us? We observe red pulsed laser. We observe that red pulsed laser accelerating, which is not supposed to happen from Einstein's theory. We observe it concussing at the venturi. We observe at the venturi, just prior to its explosion, the 2p2h particles that Bill should know about from Cornell. And then we observe these things dividing, which is what CERN wants to see, which is the muon neutrino, the black ball. It never changes. It can't concuss. It can't compress. I showed this before very clearly, I hope. If you missed it, go back and look. So that's the first part. Now, what did you observe around you? You observed something that is hard for you to believe, but it's true. It's fission, it's fusion, it's desktop, it's clean, it's cold, and it's enormous, tons of increase of energy. And that increased energy, I see no reason whatsoever that we can't harvest that energy right there, because our original input energy was, let's say, 1 watt. We should have 200 watts coming out of there. 200 times, not 200%, 200 times. And here's how we would harvest it, just as simple as this. Run that through the Venturi and collect it on, I think what we should be using now is transition metals for solar collection, because it's different than silicon, but it should be able to harvest more electrons because they have the deep holes in the orbitals, and I'll talk to you about that too, Bill. And we should be able to run this, and if it took 5 watts to run it, we should end up with 1,000 watts of energy back here. You know, how much we can harvest out of that, I don't know. Let's say it was 20%, that's still 200 watts. Or whatever it is. I mean, you get a huge increase. It's free. And this is portable. You could carry it around in a handbag or whatever you wanted, like they used to do in the Sumerian times. And talking about that, my mud fossils is another area I'd love to discuss it with. How big is your brain, Bill? How big is you guys? Is your brain going to fall out? Hold on. Let's see if it does. Put a helmet on just in case. All right, before I get started, I just want to apologize for being rude, and I have been very rude to a lot of people because I have to be. I have not had one person engage with me over the course of 50 years I've been doing the electronic stuff and the nuclear theory, but nobody will engage, so what do? But now I have the evidence, and I say we can get free energy, and if I can't get anybody to talk to me, which I can't, Fermi Lab, Don Lincoln, I've been doing debates about him, and Kirsty Duffy there online, same things I have to do with Bill Nye. I've tried to contact every one of these people, and not a single one has ever contacted me back, so I turned rude to get attention. Now, once I get attention, I can be very pleasant, but I find it very frustrating, and therefore I decided, like Velikovsky, they destroyed him. He wasn't rude enough. He was just too eloquent. He was too nice. He was too submissive. He tried very hard to get his point across. It doesn't matter. You can have all the evidence you want, and if they won't listen, they won't listen, and that's what happened. Same thing with Tesla, same thing with Velikovsky, same thing with me, and the same thing with everybody that's doing the same kind of research I am. And so I went across the board knowing that they didn't even understand how particles work. They don't understand space is not a vacuum. Light is particles. They're everywhere. Space is saturated with particles. We're scrubbing through it. That's why our global warming is happening. It's a scrub. It's not carbon. It's the expansion. It is carbon dioxide because it's an expansion gas, but it's just not carbon dioxide. It's not the carbon. It's the expansion. Now, anyway, we're going to get into Bill's story, and I like I say, I'm being a little critical and I'm being a little obnoxious. It just happens to be my way. But after 10 years, I deserve to be obnoxious. I've been obnoxicized against for 10 years, so I can obnoxicize myself against these people. I'm going to try to be nice, but we're going to have this debate series, and I will debate them in absentia, unless they will discuss it. And if they will, that's super. I would love that. On any subject whatsoever, any science, any of them, because when you realize that literally nothing is right. I mean, my mud fossils, if this goose can turn into a rock, which it did, there's its feathers, and there's a goose, and its feather pad is all what they call feldspar. They don't understand what feldspar. They don't understand what basalt is. There's so much that is not understood. They don't understand what gravity is. They don't understand mud fossils. They don't understand any of the things that I've studied. They don't understand nucleophilic substitution. All of these things I have studied. So somebody debate me. That's what I want. Here we go. Okay, I'm going to end it here for now. But I'm just going to wait for Bill to get back to me, because obviously, from what they're saying, he probably right on doing an email right now as we're speaking. But here goes. Listen.
Everybody thinks they're right.
You have a worldview. You're presented with evidence that conflicts with the worldview, so you either have to change your worldview, which is hard, because you've lived your whole life with it. Or you just dismiss the evidence and dismiss the authorities.
What makes
All right, dismiss the evidence and the authorities. Well, who's the authorities? That I'm not sure about, but we'll find out. But Bill really sounds like he's really interested in reality, and I think I'm going to present stuff that is reality, and I already have, but I'm going to present a lot more of it. And I'm sure Bill will contact me. If he doesn't, you should go up to his page here and see if he's interested in, you know, discussing and debating with me. I'd love to do it, or do a Zoom meeting, or we can show each other our stuff and we'll have a good time. Here goes.
makes sense to the universe is not the same as what makes sense to us. And we can't impose our beliefs on the universe.
If I was going to teach my students how to think critically, what are the key points? Like just basic questions they could ask.
All right, that's the key. Ask questions. And don't just dismiss something because it sounds too spectacular to be real. That's just impossible. Forget about it. No, it's not impossible. And do not forget about it. If you haven't seen what I showed or will show, watch again. Because this is consequential. This is not just fluff and exciting stuff, although it is that. Oh, yeah. Anyway, have a good time. I love you all. Peace on earth, goodwill to all men. All women, too, obviously, and every other type of person there is. I mean, I don't discriminate.